Okay, so we've got a question here that is involved in measurements, and they've been given to a given accuracy by the use of the words correct to the nearest 5 millimeters. So again, it's about recognizing key parts of questions. So when we get these words correct to the nearest, it's telling you it's about accuracy, and therefore this question's going to be about bounds. And when we read the question, it does mention the idea of calculate the lower bound. So the first thing we need to do with these questions is, once we realise it's about boundaries, then we need to work out the lower bound and upper bound for each of the measurements given. And to do that, we need to be thinking about what is the accuracy, because the error, in other words, what causes the lower bound and what causes the upper bound, is always going to be a half of the accuracy. So we can see here that it says correct to the nearest 5 millimeters. So that is telling us that the error must be plus or minus 2.5 millimeters, half of that. And for this measurement here, it's again the same accuracy, correct to the nearest 5 millimeters. So again, the error will be a half of that, and so it's going to be plus or minus 2.5 millimeters. So we can see then that the length has a lower bound of 642.5 millimeters and an upper bound of 647.5 millimeters, and a width of 397.5 millimeters and a upper bound of 402.5 millimeters. Now all I'm doing to get these boundaries is I'm adding and taking away the error from the number they gave us as correct to. So to get this 397.5, I did 400, take away the error of 2.5, and that gave us that. Now if this accuracy here was, say, correct to the nearest 20 millimeters, then the error would have been plus or minus 10 millimeters. So whatever number was here, you would have taken 10 millimeters off to get the lower bound and added 10 millimeters on for the upper bound. So that's part of what this topic's about, working out what the error is, how far apart the lower bound and the upper bound are from the actual measurement given. I mean, technically what they're talking about, just to remind you guys, is that they're measuring in, because they're saying correct to the nearest 5 millimeters, then they're measuring with a ruler or something, or a tape measure, or electronically, digitally, using gaps of 5 on the scale. Whatever they were measuring has come to somewhere in here, and because it's less than halfway between these two measurements on the scale, then it was given to the nearest, in this case 400 for the width. If it was over here, it would have been given us 405, of course. So this must have been the boundary halfway between those two numbers. So the question is asking us then to calculate the lower bound for the area. Now we recognise, again, it's about formulas, so we should be thinking, what is the formula for the area of a rectangle? Well, it's the base times the perpendicular height. So we've seen here then that the base length is going to be either of these two numbers, and the height, technically the width of the rectangle, is going to be one of these two numbers. All we've got to do then is, because of the lower bound, we've got to remember that if we're creating a lowest answer, then we're going to need the smallest length times the smallest width. So in this case, we're going to need the smallest length of 642.5 and times that by the smallest width of 397.5. And again, calculate a question. So 642.5 times 397.5 equals. So we get an answer of 255,393.75. This is about millimeters, then the answer will be square millimeters. So 255,393.75 square millimeters. Now it says give the answer correct to 3 significant figures, so be really carefully go back and kind of tick off what you've done to make sure you've recognised every sentence and every word. And 3 significant figures then means that we find the first non-zero digit and we count along 1, 2, 3. So that means we want to cut the number here, and when we look at it, then it's 255,000. So that column's in the thousands. So it's saying to us round to the nearest 1,000. So the answer is going to be 255,000. So here, 200 in the answer line, 255,000 square millimeters. Okay, so a quick reminder about ways of working with upper bounds and lower bounds involving accuracy of measurements.